So we're going to go ahead and we're going to do our polynomial division first, and then we'll do synthetic and kind of see the difference in the workload between the two. So we have 3x cubed, we have a negative 2x squared, we have 0 x's, and negative 5. And we want to divide that all by x plus 1. So we need to ask ourselves, how many times does x go into 3x cubed, which is 3x squared? 3x squared times x, 3x squared times 1, oops, 3x squared, all right, and then subtract, subtract. So negative 2, negative 3 makes negative 5, and then we do it all over again. So x is going to go into negative 5x squared, negative 5x times. Do our multiplication here. And then subtract, subtract, which changes it to add and add. These obviously cross out, and you're left with 5x. Bring down your negative 5. And then one more time, x goes into 5x 5 times. And then we subtract, subtract. So even though it looks like these should cross out, we actually get a remainder of negative 10. So the way we're going to present our answer is we're going to write our quotient, 3x squared minus 5x plus 5, and we're going to pair it with the fractional part of the quotient. So we have to put our 10 over x plus 1, and that is negative, so we just write minus. All right, then we turn our attention to synthetic division. So we're going to do 3, negative 2, 0 x's, and negative 5. We're going to draw our L with those numbers inside, and my 0 would be negative 1. Right? Set that equal to 0 and solve, you get negative 1. So we're going to bring down our 3 to get started, and then start multiplying. 3 times negative 1, and then add. Negative 5 times negative 1, add, and then one more time, 5 times negative 1, and add. We began with an x cubed, with an x squared, an x, and a constant, so we decrease everything by a power. So this will now be 3x squared, negative 5x, positive 5, and then we have a remainder of negative 10 over x plus 1. So you can see that synthetic division, when it's applicable, is a lot more convenient than long division. But long division can work under any circumstance, so there's a little bit of give and take for those. So we have 4 examples where we're going to try using polynomial long division. So I'm just going to really quickly set them all up, and then we're going to go ahead and run through them. So x goes into x squared, x times, multiply, and then subtract, which changes that to add. And then we do it again. X goes into 9x 9 times. You get 9x minus 27. Subtract, but change to add. And you get 39. So my answer is going to be x plus 9. And I have a positive remainder of 39 over x minus 3. Right. Notice in my setup for number 2, instead of just jumping from x squared to negative 16, I filled in a 0x so that everything is in nice descending order, both inside and outside. Just helps you stay organized. So we have x squared into x cubed goes x times. And then we're just going to multiply. So x times x squared is x cubed, x times 0x is 0x squared, x times negative 16 is negative 16x. So notice everything goes with the correct term. We're going to subtract, subtract, change that to add. These go away. You're left with negative 4x squared and positive 16x. And then we're going to do it all over again. So x squared goes into negative 4x squared, negative 4 times. Do your multiplication. You're going to get a 0x again, and negative 4 times negative 16 is 64. And it's up to you if you want to bring this 0 down. It really doesn't matter. You can if you just want to follow the process, but you're still going to get 64 either way. So then we're going to subtract, which changes this to add, subtract, subtract. And we get 16x minus 64. So my answer typically would be presented as x minus 4 plus, I take my remainder and I put it over top of my divisor. No need for the 0x anymore, it served its purpose. Now normally you'd circle it and be done. However, I happen to notice we have a difference of squares in the bottom and there is a GCF in the top. So just to make sure, you should always make sure if anything can factor, you factor it to see if you get any common terms. So I can factor out a 16 and get x minus 4. And I can factor the difference of squares into x minus 4, x plus 4. So if you notice, you have x minus 4 both in the numerator and denominator. So we want to go ahead and cross-reduce those. And we're left with x minus 4 plus 16 over x plus 4. Now if you wanted to, you could have switched the order. We could have done this first. We could have factored out x squared from the dividend. And that would have left us with x minus 4. And we could have factored the divisor into x minus 4 and x plus 4. So we could have done that first and crossed these out. So your new problem would have been x squared divided by x plus 4, and that would have shortened your workload a little bit. So it's a matter of preference, but I would encourage you to try to be observant and see that, but just in case you miss it, not a big deal. You can make it work. Just always double check your answer and make sure it's fully reduced. So I'm going to go ahead, I'm going to pause the video and work up number 3 and 4, and go ahead and do that, and when you're done you can unpause and check your work and answers. Alright, so number 3 worked out really nicely. We got a remainder of 0, so your answer is x squared plus 3x plus 6. Number 4, there are two ways to go about it. You can absolutely go with my setup and go ahead and do your division. The only thing is you have to check your fraction because you do get a remainder and make sure is there anything that can factor out. And yes, you could divide everything out by an x and reduce that to 11 over x minus 1. So you can certainly go that method, or if you're observant enough to realize, hey, there's a GCF of x right here and there's another GCF of x. You can do that factoring and reducing first and then do your long division. It's not going to matter, whatever your preference is. So in my next video we'll go ahead and look at synthetic division for 4 more problems, and then hopefully we kind of have a grasp on how to do each one.